Hi, I'm Jana Tidwell with Schrickle Rollins and Associates, and I'm here with my colleague Larry Stone, who is a civil engineer. We apologize that Mother Nature got in the way today of your tour of the green at College Park, but we're very excited that technology is here to bridge the gap and help provide that information for you that you would have missed out on by not taking the tour. We're very excited about this project, the Green at College Park. It's here on the UTA campus. Our firm is a multidisciplinary firm of civil engineers and landscape architects, and this was a great opportunity for us to work collaboratively. This project showcases a lot of sustainable features, and it actually was a pilot program for the Sustainable Sites Initiative, and it was one of the first of three projects in the nation to be certified, and it received a one-star certification. It is also designated as LEED Gold, and it has received a Texas ASLA Design Honor Award. In order to talk to you about the green at College Park, we really need to look at the entire stretch of the western boundary of the campus. At the bottom of your screen, you'll see that there's a road that runs along the University of Arlington campus, and that road is called Center Street. The university approached our firm and told us that they really felt like they were turning their back to the city of Arlington along Center Street, and they wanted a new front door from the campus into the city. And they wanted to start that with the first project, which is the Green at College Park. And you'll see it's the project located on the far left-hand side of your screen. Initially, the client came to us and talked to us about a vacant piece of land that they had. Actually, it had apartments on it, but it was about to be vacant. And they were searching for a use for this piece of property. And we did a lot of site analysis and discovered that there's a lot of students living in residential units on this side of campus, but there's not a lot of green space. And we actually found students late at night playing frisbee and soccer and baseball in the asphalt parking lots that were lining Center Street. So we approached the university with an idea of having a park and letting that park have a sustainable message and letting the green that was there be the new front door into the city of Arlington. And as we were working on this project, the university had plans to construct a special event center, and that center was actually supposed to be located on the southeastern side of campus. And they felt that the park was an added amenity to the special event center, and that they complemented each other very nicely. And the location for the event center was relocated to become adjacent to the park. We were hired by HKS Architects to be the landscape architect on that project, and the concept became that it was a building and a park. And we saw the opportunity to actually design both sites so we would have a seamless park-like feel that wrapped around the building. As you get to the far right-hand side of the screen that's very colorful, this is a mixed-use development that was planned by the university. Jacobs was the architect on that, and we were the landscape architect and the civil engineer. So we had a lot of great opportunities to design an entire corridor along the western boundary of the university and have it be a very fluid, seamless approach. This is what our park first looked like. It was a lot of asphalt paving. In fact, it was 82% impervious. 8.5 acres consisted of the Green at College Park and College Park Center, the special event center. The College Park, the green itself, was 3.5 acres of land. The little bit of area that we had that was impervious, I joke that it was grassphalt because it was really degraded asphalt that had a lot of grass cropping up in between it. So our pervious area was not the highest quality. At the southern corner of the park, we had this drainage channel. And this drainage channel taught me a lesson. When a client comes to you and tells you, oh, by the way, you should probably be prepared that something big is going to be thrown on your plate. And that was this drainage channel. The client told us that, oh, by the way, there's this drainage channel and we have some drainage issues that need to be solved with the construction of this park. And as we started analyzing what that meant, um, the dollar value came up that we were looking at an $800,000 solution, and the planting budget for the park was $800,000. So our team of landscape architects and engineers had to work together very collaboratively to find a solution that still created a unique, inviting place for people, but solved the drainage issues that they were experiencing. Even they were having flooding even during very low flow events. And to really discuss what it was we found when we got to analyzing this drainage channel, Larry's going to talk to you about that and some of the issues that came up.
Yes, we discovered that there near the corner of Mitchell and Center, where there was the head wall with a 48-inch pipe where this little drainage channel would empty into. More times than not, and again, as Janice said, rainfalls that weren't that intense, the street would flood, and there have been occasions where the street became so flooded, water topped the curb and flooded the apartments on the opposite side of Mitchell Street. That was, to us, was an indication that there was a significant amount of water coming to this spot. And since there were no updated drainage area maps for the university, there had been a lot of development of the university over the last several years. We decided we needed to accurately determine how much water is coming to this spot. So another engineer and I walked the site, and as you can see on this exhibit, we mapped out the drainage area based upon walking the campus. The little purple area is the park area itself, along with the Special Events Center. And what we determined was that there are 45 fully developed acres that are draining through this 3.5-acre park. That's why, to convey this water through the site on down to a tributary of Johnson Creek, we would be using massive box culverts, again, which would have blown Jana's planting budget. So we had to become very creative in how we solved this problem. Now, looking at existing conditions, here you can see the apartments there in the lower left-hand portion of the site that Jana was referencing. The Special Events Center blocked off what was 3rd Street that ran from Pecan Street, which is Spagnolia Way now, to Center Street. That was what we would call positive overflow. There is a low point in Pecan Street, and when water got to the point to where it got curb deep, it would flow down 3rd Street to Center Street and then south to Johnson Creek. However, with the new footprint of the Special Events Center, the low point was sitting right at the location of an entry into that facility, and 3rd Street was blocked off, so water had nowhere to go if there was ever an issue. We alerted the university of this problem. As a result, we added a 50 or 60 linear feet of inlet space there and created a 100-year design at that point. But as a result, you ended up having a 6x4 box culvert exiting that area. To come up with a solution that would work from a drainage standpoint, but also from an economic standpoint, we came up with what we call a storm spring. And the park itself is an oval garden, and at the lower end of this oval garden, we designed a storm spring. Coming into the storm spring is the 6x4 box culvert. Exiting it is a 48-inch pipe that ties into the existing 48-inch pipe that goes south from Mitchell Street. So as a result, in large storm events, water actually pours out of this storm spring and backs up into the oval garden, which serves as a detention area. And then that allows the water to slowly filter through the real garden, through some check dams to an outfall structure. And so that's a major component of handling a really significant amount of runoff. But along with that, we use some very creative ways to manage stormwater from other areas and from on site. And Jenna's going to share some of those with you.
So our team realized real quickly that a 3.5 acre site could not manage 45 acres of water. And we had to make some compromises on how much water it was that we could manage. And in doing that, we developed a hierarchy of stormwater management priorities. And priority number one is it seems very simple and effortless. Design the site to be a green sponge. However, I've learned living in north central Texas that that's not always an easy thing to do. My background is originally from New Mexico, and the way that we manage stormwater in New Mexico is very different than how it is managed here. We do not have a lot of municipal infrastructure that includes curb inlets and area drains and conveyance channels. We actually drain a lot of our stormwater through the roadway system off of the roads and into landscape areas or areas of green, and in New Mexico's case sometimes areas of brown. Um, but in doing that, we're very efficient at recharging our underground aquifers that our development rests upon. Now, I understand in north central Texas that we have high clay soils, and water does not infiltrate in those like they do the sandy soils that we have in New Mexico. But that does not mean that water cannot infiltrate into the soil. In fact, if we use the amendment of organic matter into our soils, and we pay a lot of attention when we develop projects at bringing those soils back to their natural, healthy state that includes organic matter, we can be more efficient at infiltrating water into soil. Um, some other very simple things is sheet flow water across the landscape. Don't control it into one area and focus it across an area because it's going to cause erosion control or erosion issues, and it's going to limit the amount of water that can actually infiltrate into the soil column. Reducing impervious surfaces and slowing down the flow of water across a site are all very important to this priority number one. And then priority number two, improve quality of stormwater, arose from the realization that we can't manage everything on our site and we can't infiltrate everything into our site. In fact, it's very important to our area lakes and streams to have runoff. We just need to be more efficient at how we manage it. And that means we need to hold water onto our site and allow it to slowly release from our site to help prevent some of those erosion and overburdening issues that we currently are experiencing in north central Texas. And another thing that we realized is if we can't encourage it to infiltrate into the soil, we can clean it and send out a higher quality water before it leaves our site. And we do that by filtering water through vegetated areas and through the soil column. We encourage water to slow down and let suspended solids settle out. And we select plants that work in conjunction with the organic soils and the microorganisms in the soils. Their roots actually start to break down pollutants that are located in the water that's flowing across the landscape. One of the things that we've learned from this project is when we're looking at best management practices, there's not one solution that is a good prescription for every site. That you actually have to look at your toolbox of what's available to you and use those that are best suited for your site. And in the case of this site, we realized it was not one or two isolated BMPs, but it was a series of them chained together. And as we were taking water and filtering it through these BMPs, the benefit was exponentially increasing as the water ran across the site. Now we're going to walk you around the site. This would have been the tour that you got this afternoon. You'll see that there's water in these pitchers, just like there's probably water out in these beds themselves today if you have a chance to drive by on your way home. Uh, this is the beginning. We're just going to kind of work our way at the north end of the project and then walk our way around, looking at where a drop of water falls and how we've managed it. This is along Pecan Street, or what is now called Spaniello Way. It is at the intersection of 2nd and Spaniello, and it is a pedestrian walkway that connects a bus stop all the way up to the front door of the College Park Center. Uh, if you notice, there's a huge roof located in this area and not a lot of real estate to manage the stormwater. And the solution of this is that the roof drains of this building are actually emptying into planters that we call flow through planters. These flow through planters have a 3-inch rock mulch layer, and that mulch is very large. This isn't typical of a rain garden, but we have some velocity coming because of the height of this roof through the area, and we're actually using the rock to hold the plants and the soil into place. But as the water enters these rain planters, you'll notice we have a little bit of freeboard for water to be stored up to the curb, and it's also stored in the pores of the rock. And then there's a pervious soil mix about 24 to 36 inches deep. And this soil consists of native planting soil, sand, compost, and expanded shell. And the rainwater actually filters through this column, and at the base of this column is a perforated pipe that water enters and it drains into our area's storm drain system. It is cleaner, though, once it leaves the site. As we walk around the front of the project, there's a fountain at the front door of this huge facility. And it was really important to some of the key stakeholders on this project that there be a fountain located at the front door. And as a design team, we really struggled that we were making so many sustainable efforts, yet we were using potable water to feed a fountain. And the solution to this issue that we were having came from the condensate that comes off of this side of the building from the HVAC system for the event center. A building like this is very unique as the air conditioning system oftentimes even runs in the winter. When you fill a facility like this up with people, the temperature rises and the air conditioning system comes on, and it generates a lot of water. In fact, this project was being completed and the fountain was being filled up as they were doing commissioning on the building in December, and there was enough condensate generated to fill the fountain rather quickly. Um, One of the, I guess you could call it a drawback. I really don't see that it's a big obstacle, but the fact that there is condensate in this fountain, there is a patina from the metals in the water that is located all along the base of the fountain. If you'll go out there, you'll see kind of that verdigris color that's indicative of copper being in the water. We did analyze a pumped filtration system that would remove these metals, but um, the cost of replacing pumps 2 or 3 times over the lifetime of the project. And as a design team and an owner, we decided to live with the patina and just let it be a unique feature of the fountain. Along the western side of the project, we have a lot more real estate to manage, and we can make a bigger impact on how we're managing stormwater along this side because we have that real estate. At the very northern end of a dry stream bed that we have designed, which is purely for conveyance. This dry stream bed actually has an outfall for more condensate, so there is most of the time water trickling through this. A lot of times it's below the rock mulch and it's not very visible, but there is water constantly being fed into the system. Also coming into the dry stream bed is all the roof drains from this side of the building. There's also a high water table, and that water table is being pumped, and water is being pumped into the dry stream bed constantly from that under the sump under the building. And then there's a loading dock located at the southern end of the event center that's depressed. And when it rains, there's a pump system that kicks on and pumps water out of that loading dock into the dry stream bed. The dry stream bed is purely for conveying water into this rain garden that's located here. The rain garden is not only for conveying water, but it's also there to encourage the infiltration of water. It has a porous soil column underneath it, much like the flow through planters. The only difference is there's not a pipe at the bottom of that. Water just eventually infiltrates into the soil. Any water that does not infiltrate into the soil will overflow a rock dam, and it flows into a rain channel, which conveys water around the oval lawn. Um, this rain channel was initially planned to be for conveyance only. As we got our geotechnical reports back, we realized that there is pockets of sand throughout our site, and there's actually a very large sand seam that runs along the boundary of this project. And we felt like this was an opportunity for us to take that sand, which is very indicative of the cross timber soil that this site's on, and turn our rain channel also into an infiltration trench, which is below that rain channel, and to encourage water to infiltrate into the sand and into the soil. Um, During low flow events, it's evident to us that it's pretty efficient at doing that. There's not a lot of water being conveyed around the rain channel. The picture here is shown after a series of back to back rather high storm events that were in 2012 after we had a series of tornadoes. Was that 2000? In 2012. Um, it was the tornado storms that we had last April. So this water was rather high. In fact, I think this is one of the highest that we've seen coming through the rain channel. And everything eventually makes its way into the rain garden. And this rain garden is very similar to the one that you saw up by the Special Event Center, except it's also intended to be a place for people. You'll see that we have walks actually winding down into the rain garden, and a lot of different plants and places for classrooms to sit and learn about the environment. And it's a place for people to learn about nature and the dynamics of rain as much as anything. Typically, on a conventional design, this whole area would have had a pipe that went underground and it could have been rather level. And we think it's actually a more interesting place, being like it is right now, with more grade change and more of a dynamic plant palette. One of the interesting things about the rain garden is it really celebrates the seasons of north central Texas. We have in this area 50% of the plants are native to north central Texas. 75% of the plants are native to Texas, and we do have 25% that are adapted. One of the, you know, constraints that you have coming up with a rain garden on this size or this scale is locating native plants in the quantities that we needed to be available. So there were a few plants that we selected that were adapted just because they were readily grown in the horticultural industry and available to us and would be quite efficient in working in the rain garden. Larry talked to you previously about a storm spring that would be function like a reverse inlet, that during very high rain events the water would actually come out of that storm spring. And this is the detention lawn, or the oval lawn, that water flows into and is stored, and then it is slowly released and drained underneath a walkway into the rain garden that I just showed you. This area here, the parking lot, located at the southeastern or southwestern side of the project, it was really not in our project boundary or our scope, but we realized that this one isolated point where this entire parking lot was draining into our area was going to cause some issues with erosion. And we saw the opportunity to remove the existing curb that was there and install a slotted curb and allow the water to spread out and sheet flow across the landscape and through a vegetated area. And it actually drains across a pervious paving that we have that's made out of recycled glass. And during very low flow events, it filters through that pervious paving and drains below grade into the rain garden. This is a higher rain event where water was actually still draining across the landscape into the rain garden. And as I mentioned, we cannot manage all of the water on our site, and that we do have to plan for overflow. And Larry's going to talk to you about how we design that overflow to be very strategic in allowing us to manage stormwater.
As you can see, this structure here has three different levels. There's a slot there at the bottom level, and basically what that does is that will handle rainfall from a 5-year event. You go up one level, and across the top of that level is another slot, another opportunity for drainage, and it handles the 25-year storm. The third level has a slotted drain there that will take care of the 100-year storm, and then we have about 18 inches of freeboard as well. So the lower end of the park can really store a significant amount of water in an intense rainfall event and slowly release it back into the storm sewer system in a way that's manageable so that you do not have the downstream flooding.
And the final component of this project is education about managing stormwater in north central Texas. We feel like just introducing rainwater into the landscape and making it visible to people who are using the park is a big step. A lot of times, stormwater management is out of sight, out of mind. It runs into a drain or a curb inlet, and the normal person who doesn't deal with grading and stormwater on a daily basis, it never even enters their mind that we're taking away habitat, we're overburdening our streams and causing erosion. And this actually allows people to interact with the site. We've come up with this sign that helps explain it. I hope one day what we've done in this garden is very intuitive and people get it and a sign is not needed. But until then, this will be an educational tool for the facility. That concludes our video tour of the green at College Park. Once again, I apologize that the rain kept you from getting out there and seeing it. There's still a lot of interesting features if you want to drive by on your way home that you can see from the roadway very easily. And we invite you to do so. And if you have any questions, feel free to contact us. We've included our email addresses below, and thanks for the opportunity. We appreciate it.